This is a screencast reassessment for CO4d, and the question is about the small car that exits an expressway. So it tells you the mass, which is 1,550 kilograms. We don't know the velocity. It says the angle of the ramp is 21.5 degrees, and then there's no friction when the car is on the ramp, and then the radius is 49.7 meters. So there's actually two ways to do this, and so I just did it both ways. The first way I did it was easier, but it didn't really help me with my other part of my answer. So my free body diagram was right here, and this way I tilted my axis, so then the force normal was directly going up and it was positive, and the weight was pointing directly downward, so the weight had the sine and cosine components to it. So if you do the sum of the forces in the x direction, it'll give you the velocity for part A, but some of the forces in the x direction was, so it's just that component of the weight. So the weight times sine of that angle, because it's across, is the only force acting in that direction, and then it equals ma, and since it's on a curve, it's going to be centripetal. And so the acceleration is going to turn into v squared over r, and then you can solve for v since you are given the radius, and v for part A turns out to be 13.6 meters per second. And then, so the other way I did it, it was harder to set up, but it gave me the same answer. So I did some of the forces in the y direction first, because this free body diagram had both the weight and the force normal having components, because the coordinate system was just normal straight up and down. So then we knew the weight, we had everything else was the same, those knowns. So I did some of the forces in the y direction, so you have the component of the force normal and you have the component of the weight now. So so when you actually do it, you can assume the acceleration in the y direction is 0 because it's not moving off up the off the ramp. It's not flying up. So since those are the only two forces and it equals 0, the formula tells you that the component of the force normal is equal to the weight. So then if you solve for the force normal, you get 163,000 or 16,342.7 newtons. And then if you do the sum in the x direction, you have to use the centripetal then, and since it's tilted now, the forces are the forces are in the x direction gonna be the component of the force normal going straight up, and then so force normal sine theta, the component of force normal, is going to equal ma, and then since in the x direction it's going to be centripetal, it's v squared over r, and then you simplify it, so force normal ends up being mg over cosine theta, because that is what we solved for up here. So you plug that in, and then the m's cancel, and then you simplify, so sine over cosine equals tangent, and then you know g, you're given r, you know theta, so you solve for v, and you get 13.9 meters per second, which is about the same. It's just different due to rounding, I'm guessing. And then, so it asks you for speed in part A, and then part B asks you for, which way will the friction force point if the car does not skid. So, originally, I just drew the picture here. Originally, I thought the friction was just going to go down the ramp because of my free body diagram, but then I realized that that wasn't on the curved part. So if I drew it on the curved part, I thought it was going to go down this way, but if you drew it on the curved part, there has to be friction going towards the center in order for it to stay on the track. So friction will point down the ramp, but in the y direction, friction will also point in towards the center. But the in towards the center is the most important part, so that it actually stays on the ramp without skidding. And then part C asks about mass, and then in both cases, mass didn't matter when I found velocity because the mass canceled out, so mass should not affect the equation at all.